Continuing our geostrophic balance for the atmosphere, the compressible fluid, we want to move the geostrophic balance into the pressure coordinates. So start with our geostrophic balance. UGVG is minus 1 over F rho dp dy and 1 over F rho dp dx. And what are you going to do? You take a z equal constant surface and you try to follow the constant pressure line, and you derive these equations in a simple way. So let's say we have point A where it's intersecting, the pressure contour is intersecting a constant height surface, and you have another point on the same height, and then you have another point on the isobar or the constant pressure line. So we're going to derive gradients in these directions and write our geostrophic balance. Fairly straightforward, right? So PA is P0, this is the constant pressure line we are looking at, and ZA is Z0, that is the height contour that we are dealing with. Obviously PB will also be P0, and we have to figure out what PC will be and what dp dx and dp dy will be in this case, right? So looking at this again, dp dx on a constant z surface is going in this direction. So we go PC minus PA, PA which is P0 because that's where the pressure surface is intersecting the z surface, divided by delta x. That's fairly straightforward for small delta x. Then we write dz dx at constant p, right? We are in the pressure coordinate. That's going to be zb minus zc divided by delta x. Okay, so we are deriving dz dx. So delta z, delta x. So don't be confused. Delta z, delta x is zb minus z 0 or zc divided by delta x. Just a fancy way of doing things. Now let's do our hydrostatic balance dpz dz plus g rho g equals 0, and write that here. So pc minus p0, pc minus p0 divided by zb minus z0. So that's our dp dz. Okay. Don't be confused. dp dz is delta p divided by delta z. Okay, so that's the same as pc minus pb divided by zb minus zc. Okay, so that's minus dp dz equals g rho. Okay, make sure you understood it. Okay, pc minus p0, p0 is here and here. So we are going in this direction because we are trying to write dp dz. This is the z direction. So we're going to write pc minus pb, which is same as p0, divided by delta z, which is zb minus z0, because we are writing minus dp dz. That's equal to pc minus pb divided by zb minus zc. We're just writing, being a little silly there. Nonetheless, pc minus p0 just becomes g rho zb minus z0. Okay, so dp dx is pc minus p0 divided by delta x. So dp dx is rho g dz dx, and dp dy is rho g dz dy. We didn't do any magic. We just rewrote dp dx and dp dy in terms of dz dx and dz dy in a pressure coordinate. So that's why this is p, constant p, pressure coordinate, right? So in that case, we can just write the geostrophic vector as 1 over f rho z hat cross grad p. We have converted the equation from here to here. So we're going to replace z hat by z hat p. This is the pressure unit vector. So it's not, it's going from higher pressure to lower pressure, as opposed to Z, which goes from lower height to higher height, right? Z goes from the surface to higher altitudes, whereas P goes from surface pressure to decreasing pressure. So just be sure you understood that. But now rho is gone. That's what we wanted. Cross dp dz. So you can see the parallel expressions. This is in the pressure coordinate. This is in the xyz coordinate. Why did we do that? As I said, the last expression allowed us to get rid of the density, which is what we had done before as well, right? When we defined divergence or mass continuity in the pressure coordinate, we got an expression that looked almost like the incompressible fluid non-divergence equation, except it was dw dp, or d omega dp, where omega was the pressure velocity. Okay, so the same trick we are using here. So just look at them again, make sure you're not confused. It's fairly straightforward, not a big deal, but nonetheless it's important that you understand how we are taking geostrophy from the xyz coordinate to xyp coordinate to get rid of density, because that's not what we want to carry, and atmosphere is a compressible fluid, so density is variable.